Hello, my name is Andres, and welcome to part 4 of Senior Developer in 24 Hours, from the ground up. Right, so you've decided to build an application from the ground up. In this video, we're going to talk about the decisions, about all of the concerns that we have to take into account when we decide to build such an application. Because as a senior developer, one of the things that we have to do a lot is make decisions. Decisions about all kinds of things. And when we're making these decisions, we have to, for example, take the context into account. A lot of the decisions have already been taken by the organization. If you're working in a large organization, we have to take into account, for example, the skill set of the team, what we're trying to achieve, what is the value that we're trying to provide when we're writing an application. We have to understand the trade-offs when we make these decisions. Normally, there is no clear answer in which we can rely on. We have to take a look at different options and then figure out which is the best option for the particular needs that we have. And for that, we have to have a good understanding of the pros and the cons of the different alternatives we are considering. If we're working as a senior developer in a team, sometimes it comes to the point where we are responsible to break ties between two different developers or two different stakeholders that, from a technical perspective, they want to do things differently. And maybe there is a situation where there is no clear best answer. So it is the responsibility of the senior developer to come in and break any ties by understanding what are the pros and cons of the different options that are out there. We also have to be ready to pick our battles. We don't want to take a stand and try to make every decision. Sometimes it's better to delegate those decisions to either the status quo or some other stakeholder. But we definitely want to be ready to pick the battles that we feel are most important to the success of the application that we're working on. And finally, we have to be ready to defend our decisions. Normally, there is some kind of architectural review board or some other external stakeholder that will have to review some of our decisions, whether it's, for example, a specialized security team or the operations team, things like that. So we'll have to have a good understanding of why we made the decisions to be able to defend them. And as we work through all of these different areas where we have to make decisions, we are hopefully building up the skill set to have enough information, enough criteria to defend these decisions when the time comes. So what are some of the decisions that we have to make as a senior developer? When we're starting off, what language are we going to use? This might be something that is already settled in your organization, but maybe not. Maybe you have to choose from a range of languages, and you have to, again, take into account the skill set of your team, what resources you have at hand, things like that, the other components that you're going to have to interact with, things like that. Once you have settled for a language, you have to decide what version of the language do we want to use. We also want to figure out what frameworks do we want to use. When we're building an application from scratch, we're not really starting from scratch. We want to leverage a lot of the code that has been built by other organizations, by open source projects that provide frameworks that we can piece together to actually focus on the important part of what we're building, which is normally the business logic that is particular to our organization, rather than building all of the building blocks from scratch. And finally, because a framework is not going to get us 100% all the way there, it is going to give us quite a head start, but we're always going to have to complement what the framework provides with some extra libraries. So what are those libraries going to be? It's another decision that we have to make. All right, let's go a little bit deeper. We've decided what language we want to use. Now we have to also figure out what version exactly do we want to use. For example, what versions are supported by a runtime? Now that everybody, or not everybody, but a lot of people are deploying in containers, we can run pretty much everything that we want. But in some runtimes, for example, managed serverless runtimes, we might have some restrictions regarding what versions of the language we have to support, things like that. So we have to be aware of, hey, where is our application going to be deployed? What versions are supported by our organization? There might be standards that we have to follow. There might be standards that come from the operations team in the sense of, hey, what are they willing to support? So we have to be aware of that context when we're choosing exactly what language version we are going to work on. We also want to be aware of what is required by our dependencies. If we're working with really specialized dependencies, especially when we're talking about proprietary dependencies, libraries that we depend on from specific vendors, there might be restrictions regarding what language versions we can use. So, if we have very specific requirements for dependencies, we also have to be aware if they come with any particular restrictions. If we are publishing some artifacts, for example, if we're publishing libraries or things like that, we also have to be aware of, hey, what version are our clients using to make sure that whatever artifacts we publish can be consumed by our customers or clients. With that said, we also want to choose a framework. When we are talking about a framework, we want to understand what services does it provide. There are very many types of frameworks that provide different services. For example, they could provide dependency injection, HTTP REST endpoints, things like that. Once we understand that, we have to understand what extra services are we going to need to be able to make our application work. Because at the end of the day, there are many different types of frameworks that we have to be aware of. For example, we can have dependency injection frameworks that basically just work to wire together applications. We have MVC and RESTful frameworks that allows us to create web applications and endpoints that people can access in a request-response fashion. We have persistence frameworks that allows us to access databases. We have integration frameworks for event-driven applications. There are batching frameworks for that kind of workload. And sometimes we have to mix and match. But for now, at least for this particular video, we're going to focus mostly on the dependency injection part and the RESTful and MVC part. The other types of frameworks we're going to cover in future videos. So let's dive a little bit deeper into how these frameworks fit together and how we can use them to build up our application. All right. So for example, we might have a framework like Spring Boot, which is extremely popular. It is likely one of the most popular, if not the most popular framework for microservices out there. And this one provides out of the box a lot of things. It provides by default the Spring dependency injection container, which simplifies a lot of the wiring that we have to do for our application. And through a modular fashion, it can provide things like Spring MVC, which is the web component that allows us to create web applications and RESTful endpoints, things like that. We can also include things like Spring Data for persistence and lots of other modules. So Spring Boot, very full feature framework. but it is also pretty big. Uh, sometimes this is what people prefer. Sometimes people like something a little bit smaller. If we go to a different, completely different technology stack, we have Express, which is on the Node side. Again, this one in particular is a smaller framework. It provides basically just web application endpoints and RESTful APIs. So it allows you to wire routes and things like that. We're going to see a quick demo of this one in Spring Boot in a little bit, but for now, just keep in mind that this is a smaller framework. It provides the RESTful APIs, but it doesn't provide things like dependency injection because these things, since this is a JavaScript and Node-based framework, we can actually achieve that just by using the language constructs without having to have a more complicated container. If we go to the Python side, we have something like Flask. This is, again, a small framework that basically provides us with access to web and RESTful API capabilities, but it benefits from having a dependency injection framework. In Python case, for example, it can be dependency injector to make it more maintainable, more manageable, things like that, and to allow us to scale as we're building more complicated applications. And there are many other combinations. For example, if you want, again, a micro framework on the Java side, some people like Drop Wizard, which is very, very minimal. This one is completely oriented at only RESTful APIs. And again, something like this will benefit from an external DI framework. For example, they have good support for Google Juice. That will help you wire your application, and it will also help you on other things like testing the application, making it more modular, things like that. All right, so let's say that you have chosen your frameworks. At least you have a basic idea of what language you're going to use, what version, things like that. You want to start actually putting things together. Before you do that, you need to have a good idea of how your project is going to be structured. For example, will you have any components that need to be shared across different modules of your application? For example, share libraries, share models, things like that. Do you need to publish any of these components? Like I mentioned before, if you need to publish a library for your clients to use, where should that code live? And, basically, how many modules do you want to have in your application? Sometimes we can have everything together in a single module. Sometimes it's better to split it up into multiple modules so that we can reuse some of the code. Once we have some of those things figured out, hey, how are we actually going to organize the code inside of each one of the modules that we decide that we're going to have? Basically, how are we going to organize the different packages? What patterns are we going to use? How will the data flow from package to package? Obviously, we are flowing from class to class or object to object, but we still want to be able to understand the flow of the logic from a project to project, from a package to package point of view, to make sure that the application is easy to understand and easy to follow. All right, and in a little bit, we're going to go into more detail into how to structure packages. But for now, there are other things that we also want to take into account whenever we're building the application from scratch. For example, how will the application be exposed? What data sources are we going to use? What external systems are we going to rely on? Do we need any external components? For example, do we need caches? Do we need databases? Things like that. All of these things, we're stepping a little bit into the architect territory, but at least there's a lot of overlap, so we want to be aware of those things. Once we have figured out that, hey, this is how many different modules we're going to have, this is where the packages are going to be, this is what we're going to have in each package, well, where are we going to store the code? And normally the answer is a version control system. So Git is the default when choosing a version control system. There are other options, but again, normally Git is good enough for 99% of the cases, unless you have some very specialized use case. After we figure out how many modules we have to map those to how many repositories are we going to need. For example, are we going to create one repository per module? Things like this might make it easier to publish some of our code. Do we want to have a single repository for your whole application? Even if you have multiple modules, we can have everything in a single repo. Makes things like releasing and merging a little bit easier. Or, hey, maybe our whole organization has a monorepo where everything goes into one big repo that has all of the code for all of the teams. And this one is a little bit more specialized. Your whole organization likely has to be geared towards using a monorepo for this to be successful. So just be aware that this is one way that people can use a version control system, even though it's not that common. Okay, so we're going to keep focusing on Git. Now we're going to talk a little bit about some of the strategies that we can use to utilize to branch Git. For example, we are going to talk about 3 strategies in particular. We're going to talk about Git flow, GitHub flow, and trunk based. So Git flow is the more featureful strategy that you're probably going to run out there, at least, of the popular ones. We have a master branch that matches what we have in production. We have a development branch where active development is happening. We have feature branches that branch off from development, where we actually do the individual developers do their coding and then they merge back into develop. We also have hotfix branches because sometimes we have to fix things in production. Those things then get merged directly into master, and we also merge them into develop to make sure that they do not get lost. And when we feel that we're getting ready for release, we can cut a release branch that can be tested. We can fix things in this release branch. And of course, we also have to bring those changes back into develop. And when we're ready with our release branch, we can merge those changes into master. We also have some systems that are a little bit more straightforward. For example, we have GitHub flow, where we basically have a master branch and we just have feature branches that when they're done, they get merged into master. Master should always be in a position where it can be deployed to production. So, we have to maybe put things behind feature flags and things like that. And finally, there is trunk-based development. Trunk-based development is very similar to the one that we were just talking about, but we expect developers to merge a lot more frequently to trunk to make it easier to integrate across the different development that different developers are doing. So again, the idea is that work is done very piecemeal and merge into trunk as soon as possible, ideally every day, every couple of days, and so on. So, you have three different branching strategies that can help you get started to figure out, hey, now that I've stored my code, how can I break it? How can I drive the development forward? Okay, now let's say that we made a lot of these decisions. We actually want to start building the code. Sure, you could start completely from scratch with an empty directory, but most modern frameworks will have some kind of generator that can help you set up the basic structure. They will apply the framework's best practices. They will create a set of reusable templates that we can use throughout the whole development. All right, so how do we use these generators? And there are multiple types of generators. For example, the build tools can have their own generators. For example, Maven, NPM have tools that will allow you to create sample applications. There are also standalone CLI tools, for example, Express Generator, JHipster, Spring Boot has a CLI tool that will allow us to create a fully structured application very easily. There's also websites where you can use a very user-friendly way to create your application. One of the best examples is Spring Initializr. We have a demo of that coming up soon. And sometimes your organization might already provide a generator. For example, it can be a Maven archetype. It might be a CLI tool that you can leverage to get this done. And with that said, let's see a demo of a couple of generators. Let's take a quick look at a Express generator example. So the Express generator is packaged as an executable node package that we can execute using npx Express generator. So let's take a quick look at some of the options that we get. So it allows a little bit of customization. For example, we can choose which templating engine to use. It also allows us to use no templating engine and use straight up HTML. It also allows us to use a CSS engine for our styles and, a couple of extra things. For example, it can generate a git ignore file for us, things like that. All right, so let's generate our first application, and we're going to generate this application using the handlebars module for our templating. And we also want to generate the git ignore file. So with that command, we are going to get a fully working skeleton of a Express application. So let's take a look at some of the files that we got. First thing we have is the package.json, which for any node module is going to give us a lot of metadata. For example, here we have the name of the application, which in this case is demo, just like the name of the directory in which I'm working, the version. It has some scripts. In particular, we have one script to start up the application. We have the dependencies. We can also take a look at the app.json, where everything is wired together. For example, here we are starting up the Express application. We are hooking up the routes that are defining the routes directory. We're going to take a look at that directory pretty soon. The index router is mapped to / and users router is mapped to users. We also add some logic to handle errors, for example, 404 errors. Okay, as I mentioned before, the routes are defined inside of the routes directory. We have two routers. We have the index router, which is basically rendering a template named index with some parameters. In this case, it's actually only one parameter, which is title equals express. And we also have the users route, which is just sending straight up text. It is not using the templating mechanism. If we take a look at the views, we are going to see some views for error handling, and we have a view for the index, which is going to take the title, which, as we saw before, it is a parameter that is passed together. So it is a very simple application, but as you can see here, all of the different pieces have been set up for us, so it makes things a lot easier to get started. Some other things that we got a git ignore file generated for us with some sensible defaults for a Node application using Express. We have a script to start up our application. All right, now let's see the application in action. Before we run it, we need to install the dependencies. As I showed you before, the dependencies are already defined in the package.json. So this shouldn't take long. Okay, great. Now that we have done this, we can start up the application. We're going to start the application with npm start, and we're going to add some debugging. With this, we see that our server is running in port 3000. So let's take a look at how it looks. All right. So if I go to localhost, what I'm going to see is the index route, which is rendering one of the templates, and it is passing express as the parameter. We also have another route, which is the users route, which is going to send some plain text back to the user. And with this, we can see how with just a very simple command, we get a fully working Express application with the different directories set up and the basic structure for us to start working on. Now let's take a look at a demo using the Spring Boot generator. Now this one is a little bit different from the Express demo that I just showed you, because for this one, we're going to use a web page to generate our sample application. And if you just go to start.spring.io, you can use the Spring Initializr to set up a basic application using some of the best practices that Spring recommends. So in here, for example, we can choose a lot of different options for our new project. We can choose, hey, if we want to use Maven or we want to use Gradle. Do we want it using Java, Kotlin, or Groovy? We can choose the Spring Boot version. We can enter the project metadata. For example, let's say that I want to use my custom domain, Java process. We can enter a description of the project. We can choose if we want to package our application as a jar or as a war, the Java version that we're targeting. We can also add dependencies because Spring Boot has a lot of different things that we can add to get a lot more functionality. So in this case, I'm just going to add the Spring Web, which provides Spring MVC. It allows us to build web application. It also allows us to build RESTful APIs. And it uses an embedded Tomcat to run our application. So after I have configured everything, I can actually generate a zip file with my application, but I can actually explore it. I can see what files are going to be generated Here, for example, we can see that it provides me with a git ignore file. We have some basic help. We have the build.gradle with all of our metadata, the dependencies that we need, things like that. We have the files that are needed for the Gradle wrapper. And we have all of the source code. This is using the standard directory structure that was defined by Maven and that other tools such as Gradle have used. So in here, this one actually provides a little bit less functionality from this side than the Express generator. We do have the demo application. We have some empty properties files. Something that we get here that we don't get with the Express generator, we do get a very basic skeleton of a test, but that's about it. However, we do get plenty of directories where we should be placing things like our templates, static files, things like that. So with that, let's download our sample application and let's run it real quick. All right, so now that I have downloaded my application, I can just unzip it. And here what I have is basically the same structure of the files that I just showed you. Now using the Gradle wrapper, I can actually start up my application. This is going to download the dependencies, it's going to build my application, and is going to start it up. And as you can see here, we have a Tomcat server listening on port 8080, which we should be able to hit if we go back to our browser. All right, so let's do that. And if we go to localhost 8080, what we're going to see is the 404 that is returned by the Spring Boot application. Out of the box, Spring Initializr doesn't give us any controllers or anything like that, so everything goes by default to the 404. But nonetheless, we have a fully working application using their recommended structure, and from this, we can start building on our custom application. All right, so in these two demos, we created a very basic application. We set up the basic package management and the package structure. In at least one of the examples, we got some sample endpoints that we were actually able to hit. And we got some miscellaneous boilerplate, in particular the git ignore file. So with this, you can see how we can use generators to get us going on the right path with very little work from our side. All right, in the next video, we're going to start talking about the architecture of our application. We're going to take a first look at some of the cross-cutting concerns that we have to care about. All right, thanks for watching. And as usual, don't forget to subscribe and also feel free to follow me on social media. Thanks.